Some of the formulas that you need to know your sequence formulas for arithmetic and geometric. Recursive is when you have to have the number in front of it. So for arithmetic, it would be a sub n equals a sub n minus 1 plus d. So the term in front of it plus d. The explicit formula is where you can just plug in any term. A sub n equals a sub 1 plus n minus 1 times d. That is your arithmetic if you are adding to get from one to the next. Geometric sequence is if you're multiplying to get from one to the next. Recursive is a sub n equals the term in front of it, a sub n minus 1, times your common ratio, r. Explicit, a sub n equals a sub 1 times r to the n minus 1. So you can use any formula there, or any term there using that formula. So then these problems 5 through 8 are arithmetic, and then 9 through 12 are geometric. They just want you to determine if it's arithmetic, so make sure that it is. If it is, find the common difference, the 50-second term, the explicit formula, and the recursive formula. All right, so when you're handed something like this, you want to look at the terms and say, what am I doing to get from one to the next? So from 13 to 15, 15 to 17, and 17 to 19, what are you doing? You're adding 2, which means it is arithmetic. So my common difference, my D, is going to be 2. From there, you probably want to do your formulas before you do that 50-second term. So I would do my recursive formula. My recursive formula, that is going to be, if I'm looking for a specific term, I need the term in front of it, and I just add 2. Recursive. For explicit, I am going to say, I'm going to have to do a little bit of work first. A sub n is going to be my first term plus n minus 1 times my common difference. And then I'm going to distribute and plug that guy in. So 13 plus 2n minus 2. And so my explicit is going to be 2n plus 11.
Is it okay if we write it 11 plus?
All right, and then the last thing that you want to do is you want to find your 50-second term. And so 50-second term is going to use the explicit 2 times 52 plus 11. So that's going to be my 115 there. And so I have 4 answers to this particular question here. I have my common difference. I have my recursive. That's a little too big. I have my recursive formula there. He's moving around on me. All right. I have explicit formula. And I have this 50-second term. I'm going to verify that it is a geometric first of all. So I'm going to say from -1 to -2, -2 to -4, -4 to -8. What am I doing? Multiplying by 2. So that means my common ratio is also going to be 2 here. For the recursive piece of it, however, I would say to find a sub n, I'm going to take the 1 in front of it and minus 1, and I'm going to multiply by 2. For explicit, if I'm finding a sub n, I have to take my first term, which is, in this case, -1. And you do want to use parentheses here when you do your common ratio, because it will, sometimes if it's a negative especially, it's hard to tell what you're taking to the power. So you don't want to just do 1 and 2. You want to separate those out. But you don't have to simplify this guy, really. You can leave it just like that. So this is your explicit here.
When we're giving you the formula.
All right, so the last one, it wants the 8th term rate for these. So my 8th term, a sub 8, is going to be -1 times 2 to the 8 minus 1. You want to actually calculate that out for me. And so that would be your answer there for that one. So 4 answers for this one as well. Your common ratio, your recursive formula, your explicit one here, and then your 8th term. So like to do the arithmetic, you just find the average. For these, you would have to say like my 3rd term should be my 1st term times r to the 2, right? And so your 3rd term is negative 144 equals 4 times r squared. Divide by your 4 and square root it. And that's how you get what your common ratio is, and that's how you know what to multiply by. Yeah, when you calculate this out, divide by negative 4, right, and take the square root, you will get that r equals 6. But your original thing said negative 4, what you don't know, and negative 144. 6 is your ratio, so you're going to multiply those. So you would say negative 4 times 6, so that's how they're getting negative 24 as the missing one. And this was number 15. So you're just thinking this as a sub 1, this is a sub 2, this is a sub 3. You're solving for r, so you just multiply to get to the next one. So adding them up, you are taking the entire set and giving me a sum for it. And they gave us a formula for your finite arithmetic sequence or series. This is on page 608 in your books. Page 608 is where you'll find this formula. And so for this one, you need the first and the last term. What you'll notice is I did not give you the first and last term on this particular one. Now, some of them give you first and last, some of them give you a set, and sometimes it gives you in summation notation. All right, so you have to know how to calculate it every time. So what you'll want to do is you'll want to figure out maybe what your explicit is. To find the explicit, I need to find out what my common difference is. What is my common difference here? Right. And so if I want the 10th term, then I would say, well, to find my nth term, I would take my first term, a sub 1, plus n minus 1. And in this case, I specifically want my 10th term. So that would be my explicit formula. And you don't have to simplify it because it didn't ask for your explicit formula. It just wants you to summarize it. All right. So if I want to find that last term, which is what I need, I would do something like this. Right. So I would have 27 plus 8. My last term is going to be 35 here. All right. And so now I have my first term and my last term, which is what I need to do this formula here. And so I'm just going to plug it in. I'm finding the summation of the first 10. So that's going to be 10 over 2. The first term, 8, plus the last term that I calculated to be 35. So I'm going to get 5 times 43, which is going to give me a summation of 215 for this one. Oh. All right, so this is the summation of an arithmetic series. So we're going to use the formula S of n over 2, a sub 1 plus a sub n, right? In this case, my n is 13. My first term, a sub 1, is just what's going to happen when I plug in a 1 here. 9 minus 6 times 1. So my first term is going to be 3. And then my 13th term, which is my last one, is going to be 9 minus 6 times 13. Which is negative 69. So I'm going to say summation is 13 over 2 times 3 plus negative 69. You should get negative 429 here when you do that. Of a finite geometric sequence here, or series. So finite is important. This is actually has an end to it. All right. Your formula is your first term, 1 minus r to the n over 1 minus r. All right. Sometimes they gave it to you where they gave you the first term, the last term, and your r. Sometimes they gave it to you with the terms and then the number like I did here, and then sometimes they gave it to you in summation notation. So you'll just need to know how to back into these things if you don't know them. For this one, they didn't give me the r, and so I have my n, which I need that. I have my first term, which I need that, but I also need my r. And so think of these as commas if you want to. So I'm going from 1 to -4 to positive 16 to -64. So what am I doing to go across there? What is my r? Yeah, it's -4. My r is -4, okay? And so I have my first term, which is what they need. I now have my r and I have my n. So I'm just going to plug it all in. So my summation of the first 8 is going to be my first term, 1, times 1 minus, I just found my r, -4, to the n, which is 8, all over 1 minus r. And make sure you do order of operations correctly here. You do want to do your exponent first. Yes, so you want to do this -4 to the 8th power first, right, before you do your subtraction. If you put it into your calculator, it will be fine. You can do it all on your calculator, but you want to make sure you do in your calculators 1 minus parentheses -4 to the 8. And then you'll probably want to put parentheses here before you do divided by, and 1 minus -4 is 5. So make sure in your calculators you do that correctly so that it does that -4 to the 8th power. And you should get -13,107 when you do that. So I'm going to use my summation formula. S of n equals my first term, 1 minus r to the n over 1 minus r. My first term, I could just plug in a 1 here, right? So my first term is going to be 3 to the 1 minus 1, which is 3 to the 0. So that's just 1, right? My r is the number that is being taken to the power. So my r here is just 3. And my n is this guy right here that they gave me as my top number. N is 9. And so then I'm just going to plug it in. The summation of the first 9 terms is going to be 1 times 1 minus r to the n, all over 1 minus r. So in your calculator, you can actually put, 1 minus 3 to the 9 divided by -2. You put all of that in, you should get 9,841. All right, if you have a common ratio less than 1 for an infinite series, you can calculate the sum. And so the first thing you want to do is double check. Is my r smaller than 1, or the absolute value at least? And yes, it is. So that means I can use this one. And all I need is my first term and my r for this one. So this one's really easy. If I'm finding my sum here, my first term, 4.4 over 1 minus my r. And you just plug it in. And 8.8 is what you're going to get there. Which is, you could do that without a calculator. 4.4 over 0.5, which is just times 1/2. Divided by 1/2 or times 2.